Good morning, guys. I am going to lead you through the mini lesson on section 8.4, which is perpendicular, which is orthogonal vectors. So, first of all, you have your cute little packets here, and the way that this second part works is you're going to watch a mini lesson, do an investigation during class that I'll lead you kind of through, but you'll work in groups, and then you'll take a cute little Socratic quiz to see if you understand the content. The reason why we do this second part, or I do this second part this way, is because this stuff really is useful in the real world, and I think that it's better for you if you kind of figure it out on your own and make it useful to yourself. Okay, so first of all, we're going to start out by talking about a dot product. In two-dimensional vectors, dot products are only slightly important. When you get to three-dimensional vectors are really important. And then for our purposes, we're going to use the dot product actually to, sorry about that, we're going to use the dot product to get us somewhere else, which is an angle in between two different vectors. And that's similar to what a dot product does for three-dimensional vectors. In class, we'll talk about three-dimensional vectors and how they graph 3D points, which is used in computer animation. Very cool. All right, but we got to start with the basics. So the basics, what is a dot product? You take the two vectors and you're going to multiply the x coordinates, multiply the y coordinates, and add them together. So it's a pretty easy process. So for part A here, it's just 2 times 7 plus 3 times negative 1. Oops, negative 1. So we're going to get 14 minus 3, so the dot product of those two vectors is 11. Again, this will mean something to us in a moment. So for part B, negative 15 plus 35, so the dot product is 20. All right, then you have to remember that there is a difference between, two things, multiplying by a scalar and doing the dot product, because a lot of people think that that dot looks a lot like the multiplication sign, and it is. But that's different from multiplying from a scalar. So in part A of example 2, we have two different operations going on. Oh, also, this didn't transfer well to my explain everything, so you can ignore those weird signals on the top there, those little signs. All right, so on the inside of the parentheses, your Aunt Sally would say, do the dot product. So do the dot product of u. And then from there, you're going to multiply that, which will be a number, by the vector w. So let me lead you through this one. So dot product of u and v is negative 6, oops, plus negative 20. So the dot product is negative 26. That is the scalar that is then multiplied by the vector 6, 7. All right, when we multiply that, we're going to get negative 156 and negative 182. Let's redo that here. Let's see if I can delete that. I don't know why I did that. All right. So negative 156 and negative 180. Save it too. There we go. I'm now going to give you a second to do part B on your own. So hit pause right now. Okay, so let me lead you through part B. You're going to add vectors u and v, and then do the dot product with w. All right, so adding u plus v, you're going to get 3 plus negative 2, negative 5 plus 4, so you get 1, negative 1. Do the dot product with w, which is 6, 7. You get 6 plus negative 7, which is negative 1. All right, let's talk about why these things are important to us now. Dot products help us find the angles in between two vectors. So if we wanted to, for example 3, find the angle in between, let's do from example 1, 2, 3, 7, negative 1. If we want to find the angle in between these two vectors, a good thing to do would be graph it, and we'll take a look at what that looks like, but then that's not going to be an accurate representation of what we are doing. So let me take a second to graph these two vectors. We'll talk about the angle and then we'll actually find it. Okay, I have the two vectors drawn, 2, 3, and 7, -1. I don't know, that looks to be about a, I don't know, 30, nope. Let's see if I swing that up there. I don't know, 60-ish degree angle, but 60-ish is absolutely not an accurate way of talking about that angle. So to find it, I can use that equation right there. So it's going to be the dot product of the two vectors. Well, in example 1, we found that to be 11, over the length of u, you know that means the magnitude. So think about the magnitude of this doing Pythagorean theorem, square root of 2 squared plus 3 squared, so 4 plus 9, square root of 13, times the length of v, so the length of the other vector, square root of 49 plus 1, square root of 50. All right. This answer is coming out to be 0.43 approximately. We'll bring it to one more decimal point. This is what the cosine of x equals. So by taking the inverse cosine of both sides, I see that this is a 64.44 degree angle. So I wasn't far off with my 60 degrees. Not bad, Jernigan. Anyway, so starting here, we're going to be doing the investigation in class. Feel free to watch this video again if you need, and enjoy.